the next thing is distance formula. So now we're going to talk about distance formula. Distance formula is really important. We're going to be using it a lot throughout the year. You'll use it next year. You've actually seen distance formula. You just don't realize that you've seen distance formula. So before we get on to distance formula, I just want to go over some geometry notation. So the first thing is a line. Our notation, say we had AB, would have a little line over it. And my diagram would be, of course, I'd have 2 points. Points are always uppercase. Okay, 2 points on that line. So this could be line AB, or it could be line BA. Okay, next notation, so segment. And when we really get into this, you need to make sure that you have this down. So segment is going to have a little segment bar over it. So this is not necessarily segment AB. This would be segment AB. And so here is my A. Here is my B. So that's with a segment bar. My next one is ray AB. Now, when I'm looking at this ray AB, there's actually only one way that this ray can be written. There has to be an A here and a B here. This is not ray BA. Ray BA would actually, it would start at B, and this one starts at A. And this actually all rounds down to what I have right here, which is distance, okay? Now distance, there's actually math, there's a lot of shorthand in mathematics. So for distance, if I just write AB and there's nothing over it, okay, all that is saying is the distance, that is read as the distance from A to B. Okay, that's how that's read. You'd read that as the distance from A to B. So we look at our first little problem here. And it says find the distance between the points in the coordinate plane below. And so I know I'm going to be asking a lot of you, but we're actually trying to find this distance right here. So from here to here. Okay. And so, but I want to see, and you guys should have seen this at some point. I'm hoping that you saw this at some point, is I want you to see this right triangle right here. Okay, because that's really important. If you can see this right triangle, then you can solve for this side right here, the distance between these 2 points, okay? So if I can find this distance here, and I can find this distance here, I can use what's called Pythagorean theorem to find the distance across here. Because if you remember from whatever class, it should be a squared plus b squared equals c squared. So how do I find that? So how would I find this distance? Well, I can count it. It's 1, 2, 3, 4, 5. Okay, it's 5 spaces, which happens to be 6 minus 1, it's here's 6, and here's 1, 6 minus 5. So this is 5 spaces here. And then on this side, it is 1, 2, 3 spaces. I know it's 3 spaces, which happens to be, well, this is 4 right here, and this is 1. So this is actually, 4 minus 1. So where do these numbers come from? How do I get this side? I can subtract my x values here. How do I get this side? I can subtract my y values to get that. So, and so I just do Pythagorean theorem. I'm going to call this, let's call this C. So this would be 5 squared plus 3 squared is equal to C squared. 5 squared is 25. 3 squared is 9 is equal to C squared. 25 plus 9 is equal to 34, which is equal to C squared. How do you get rid of a square root? Or squared, you take the square root. And so I know my side is the square root of 34. Okay, and then that's how you'd find the distance between 2 points. But there's a whole formula for that. Okay, you guys see how I put the distance at the end? Distance formula is equal to the square root of the difference between my x's squared plus the difference between my y's squared. Okay, and all this represents is this distance right here, and all this represents is this distance right here, and all you're doing is Pythagorean theorem. That's why you take the square root. It's this squared, a squared plus b squared equals c squared. Okay, so Let's just do a couple examples. So given that A is -3, 4, and B is -6, 9, it says find. Now you wouldn't read this as A, B. This is read as, it says find the distance from A to B. That right there, that whole statement, that little A, B next to each other, is the distance from A to B. So what I'm going to do is I'm just going to use distance formula. So my distance is equal to, I'm going to do the square root. And so I'm going to subtract my x as -3 minus 6. So it's going to be -3 minus -6 squared plus, and then I'm going to subtract my y's. It's going to be 4 minus -9 squared. So my distance is going to be equal to -3 minus -6 is -3 plus 6, which is 3. So this is going to be 3 squared plus 4 minus -9 is 4 plus 9, which is 13 squared. My distance is going to be equal to 9 plus 169. My distance is equal to 178, the square root of 178. And we're going to kind of leave it like that for right now. So yeah, so it's the square root of 178. All right. So let's answer a couple more questions. The distance between D and E is 9. Okay, it says find A. So I'm still going to use distance formula, like so they're giving me a distance. I'm going to write this out. So the distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so I'm going to replace what I know in this. So I know that the distance is actually equal to 9. So I'm going to replace that with 9. Okay. I know I'm going to just say that 3 is x1, so it's going to be 3 minus a. So it's going to be x minus x, 3 minus a squared. And then plus my y minus my y, so it's going to be -5 minus -5 squared. 9 is equal to the square root of 3 minus a squared plus -5 minus -5 is 0, so it would be 0 squared. 9 is equal to the square root of 3 minus a squared. Okay? How do you get rid of a square root? Well, the square root of a square should just be the number, but if you're not quite sure about that, what I do, how do I get rid of a square root? I'd square each side. So this is going to be 81 is equal to 3 minus a squared. This is not the most direct route to do this problem. How do I get rid of a squared? I take the square root. 9 is equal to 3 minus a. I subtract 3. Subtract 3. 6 is equal to -a. Divide by -1. Divide by -1. A is equal to -6. And you're done. Okay, and you can test that in here just to see if you want. If you want to do just a quick check, I'm going to just do a quick check. So my distance is going to be equal to the square root of 3 minus -6 squared plus -5 minus -5 squared. Okay, so my distance is going to be equal to the square root of, well, this ends up being 9 squared. Okay, and so my distance is equal to the whole square root of 9 squared is 9, and so it does check out. Just as a side note, I was just checking it, but this is how you do the problem and set it up. Okay, number 3, triangle ABC has these 3 coordinates. What's the perimeter of the triangle? So what you have to do is you have to find distance 3 times. So you have to find the distance from A to B. Okay, the distance from A to B is going to be the square root of, I do x minus x, so it's going to be -6 minus -3 squared plus 2 minus 6 squared. -6 minus -3 is -3 squared plus 2 minus 6 is going to be negative 4 squared. Distance from A to B is going to be the square root of 9 plus 16. The distance from A to B is equal to the square root of 25. So the distance from A to B is equal to 5. Now we're trying to find the perimeter of a triangle. So we have the distance from A to B is 5. Okay. Now let's find the distance from, let's say, B to C. And so we do the same thing. We do this 3 times. So so I subtract my x's, negative 3 minus 5 squared plus 6 minus 0 squared. Negative 3 minus 5 is negative 8 squared plus 6 minus 0 is going to be 6 squared. The distance from B to C is equal to 64 plus 36, which is the square root of 100, which is equal to 10. So from B to C is 10. So now we have to just do our third side. Our third side is going to be from A to C. So from A to C, we subtract x minus x, so that's going to be negative 6 minus 5 squared plus 2 minus 0 squared. So negative 6 minus 5 squared, 2 minus 0 squared. So that's going to be the square root of negative 11 squared plus 2 squared. From A to C is going to be the square root of 121 plus 4. So that's going to be the square root of 125. Okay, so my last one is 125. So when I ask you what the perimeter is, the perimeter is going to be 5 plus 10 plus radical 125. And we'll talk about simplifying this a little bit later. If you know how to simplify, great, but a lot of you didn't get to it. We'll go over that in future units. But my perimeter is going to be, well, you can add things that don't have a radical, but I can't add this right here because this has a radical with it. So I just add my plain old numbers. So when I simplify, this is going to be 15 plus radical 125. And that's that. All right. Number 4 is to find the exact length of each segment and to determine whether the 2 segments are congruent. Congruent means equal in measure, if you don't know that. So we find the distance from A to B. So the distance from A to B is going to be the square root of 1 minus 5 squared plus 1 minus 3 squared. The distance from A to B is equal to 1 minus 5 squared is negative 4 squared plus 1 minus 3 squared is negative 2 squared. The distance from A to B is equal to 16 plus 4. The distance from A to B is the square root of 20. Okay, we do the same thing for the other one from C to D. The distance from C to D, it's going to be negative 3 minus negative 1 squared plus negative 2 minus 2 squared. So from C to D, negative 3 minus 1 is negative 3 plus 1, so it's going to be negative 2 squared plus negative 2 minus 2 is negative 4 squared. And I see that I have the same thing, so I'm kind of making a prediction right now that they are congruent. Negative 2 squared is 4. Negative 4 squared is positive 16. And so the distance from C to D is also the square root of 20. So they are congruent because I've shown that the distances are the same. And that is it for distance formula.